It begins with an idea, a desire for better, more exact, more reliable. We cast metal to bring that vision to life. Not just strong, but precise. Crafted to fit, designed to endure. Precision enables doctors to see clearly, bringing comfort and hope. It guides ships across vast oceans, making every journey safe and full of joy. It gives robots the grace to move, and the heart to care for the young and the old. And when our eyes can't see the details, it does, turning tiny moments into big discoveries. Every part tells a story of care, of craft, of trust, precision, not just a word, a promise to the future. Welcome to the stage, Sunrise's CEO Gilbert Chen.
Hello everyone. Welcome to the 2025 SunriseMedCoat DCTC Die-Casting Technology Conference. It's great to be here with you as we explore the next big step in manufacturing. We are standing at a critical moment. Manufacturing is no longer just about being fast or efficient. Now it's about finding better ways to work with technology, materials, and precision together. This isn't just a small upgrade or a quick fix. It's a complete rethinking of how we make things, starting from the ground up. We are asking big questions. What does it mean to go beyond the limits of traditional manufacturing? What kind of technology can we truly shape the future? We see the challenges ahead, and we also see the truth. Old manufacturing methods are too slow, too heavy, and too fragile to keep up with today's fast-changing world. Precision, intelligence, and strength. These aren't goals anymore. They are the basic requirements just to complete. When facing the unknown, we need real breakthroughs, not just improvements. Today at DCTC, we will introduce 3 powerful technologies, 3 fresh ways of thinking about manufacturing, and new definitions of what's possible. In critical moments, it's not the scalpel that decides everything. It's the tiny, precise image from medical equipment that make all the difference. To most people, it might just look like a machine, but for doctors, it's like a second pair of eyes that help them see hope. One scan, one small data error, that could mean the difference between a misdiagnosis and saving a life. In hospitals, labs, and life support systems, precision isn't just a technical term. It's a matter of life and death. And precision alone isn't just enough. These devices also have to work reliably over time. They need to handle high heat, resist corrosion, and stay strong under consistent use. If anything goes wrong, even in the smallest part, it could lead to serious consequences. That's why we ask ourselves, what if precision didn't just come at the end during assembly, but was built into the metal itself, right from the moment it's casted? Our answer is Sunrise-Clara. We use SunriseVacuCast, a vacuum die casting process. This advanced method fills the aluminum alloy into the mold in a vacuum environment. By removing the air inside the mold, it solves common problems in traditional die casting, like tiny porosity and unwanted particles. In medical equipment, even small internal air pockets can weaken the structure of a part, especially when it's used in high pressure or high stress environments. Vacuum die casting helps reduce this risk by minimizing internal porosity and ensure the material is more compact and reliable from the start. This technology helps reduce internal porosity by more than 20% in many cases, making the material more solid and consistent. That means the parts are denser and hold up better under repeated stress or heavy use. After vacuum die casting, we use our Sunrise-Makino high precision machining system. It keeps machining tolerance within 5 microns. So every key part fits together with great accuracy. This helps avoid small size mismatches that can add up during assembly. Compared to traditional methods, our system cut down assembly errors by 25%. That's a big step forward, especially for medical parts that need perfect alignment. We also developed a special surface treatment called SunriseMedCoat. It offers stronger adhesion, harder surface, and better protection against corrosion. So even after long exposure to high temperature, high pressure disinfectants, the coating stays intact. No peeling, no contamination, no drop in performance. Let me share a real story with you. A leading global medical equipment company was working on a new ICU air system. They ran into a serious problem. A tiny sealing gap of just 7.6 micron could cause gas leaks during high load use, which would affect how accurately oxygen is delivered to patients. They tried different traditional manufacturing methods, but nothing could get them both the precision and the consistency they needed. That was until they found Sunrise Corona. Once they used our vacuum die casting and Sunrise-Makino machining solutions, things changed fast. The pass rate of their parts went up. The equipment lifespan increased by 35%, and the failure rate dropped down, meaning fewer repairs and less downtime. But the biggest win, it wasn't just about better productions. It means patients could count on safer, more reliable life support when they need it most. When we talk about extremely manufacturing, the deep sea is one of the toughest places to prove your work. At 2,600 meters below surface, every square centimeter faces over 300 kilograms of pressure, enough to crush regular parts instantly. But it's not just the pressure. It's freezing cold, highly corrosive, and completely dark. In that environment, even the smallest defects in a part can turn into a big problem fast. For deep sea equipment to last down there, it can't just rely on seals or coating. The strength has to come from the structure itself, from the inside out. The problem is traditional die casting struggles in these conditions. It often leaves tiny pores or weak spots in the material, making it hard to achieve the strength and the density deep sea use demands. So we asked ourselves, if the equipment is made for the ocean floor, shouldn't the way we make it be just as tough and advanced, not just built better, but built differently from the very beginning? That's how Sunrise-Aqua was born. We introduced our SunriseClara semi-solid die casting technology. It's a cutting-edge process that blends the best of both liquid and solid metals. By controlling the metal temperature to stay in a slurry state, we get smoother mold filling and a much more uniform internal structure. This helps us avoid common issues like shearage, porosity, and cracks that you often see in traditional die castings. The result, internal porosity drops to as low as 0.5%. The parts become denser, stronger, and more airtight, all essential for extreme environments like the deep sea. But we didn't stop there. We also developed our own custom aluminum alloy, Sunrise Silicon Alloy. It's designed specifically for deep sea conditions, offers high strength, great machinability, and much better corrosion resistance. By fine-tuning the silicon content and trace element, we boost resistance to seawater corrosions by around 30% compared to standard aluminum alloy. And for the finishing touch, we applied our Sunrise MarineCoat protective coating. It's twice as thick as traditional coating, up to 120 microns. It's passed 1,000-hour source break test and holds up even after months of soaking in seawater. No bubbling, no peeling, no cracking, just solid protections all the way. Here's a story from the deep sea. A marine tech company was developing a sonar system to track fish behavior at a depth of 2,600 meters. Their goal was long-term data connections, but just 3 months into test, things started going wrong. Tiny cracks showed up, seals failed, high-pressure seawater leaks inside, short-circuit the sensors, and shut down the whole system. The engineers tried to fix it by making the walls thicker and tweaking the seal design, but it didn't really work. It just made the device bulky and expensive. That's when they realized the issue wasn't just one part. It was the whole manufacturing approach. So they came to us at Sunrise-Aqua. We stepped in and restored the entire design. First, we swapped in our customer Sunrise aluminum silicon alloy for better strength and corrosion resistance. Then we used our SlurryCast process to get a much denser, stronger metal structure. On top of that, we added our MarineCoat protective layer for deep sea durability, and the results? Pretty amazing. The same device has now been working non-stop at 2,600 meters for 18 months with 0 failures, no leakage, no rust, no faded cracks, nothing. Their project took off, and that unit became the foundation of their entire product line. It was their first big win in long-term deep sea operations. At Sunrise, we didn't just make a product, we made a promise that even 2,600 meters below the surface, performance doesn't just survive, it thrives, because down there almost isn't good enough. There's no room for error. Every surface, every joint, every tiny detail has to be right. That's what Sunrise-Aqua stands for, turning the harshest environments into proof of our strength and precision. Now, let's shift gears from deep sea to the sky. Picture this: a robotic inspector climbing a high voltage tower. Winds are howling at over 80 kilometers per hour, but it keeps going, adjusting sensors, making repairs, all while hanging in the middle air. Sounds like science fiction, right? But it's not. It's real. It's possible because the way these robots are built. Today's field robots are leaving the laboratory. They're going to disaster zones, collapsed buildings, surgeries, even up into the skies. And they're not just assistants, they're saving lives. But let's be honest, To survive in these extreme conditions, it's not enough for a robot to be smart. It needs to be strong, light, and tough as nails. It needs to be built like athletes. That's where Sunrise-Robo comes in. We tackled 3 hard truths about field robotics. Number 1, precision matters. If a robotic arm is off by just 0.002 inches, that tiny error adds up fast. It can mean the difference between grabbing something or missing it completely. Second, weight kills mobility. Too heavy, it burns more power, loses balance, and slows down. Not good when speed and agility are everything. Third, fatigue breaks everything. High speed, repetitive motions wear down regular materials, and when a joint fails in the field, it's game over. So what did we do? We started with Sunrise HollowStruct, our ultralight skeptical frame system. It's built using advanced simulations to place material only where it matters most. The result? Up to 20% weight reduction without giving up strength. Lighter robot means fast moves, higher clamps, and longer run times. Then came precision. We combined Sunrise-Makino CNC machining with Sunrise-Zeiss UltraMetrology. This combined gives us joint with error under 1.5 microns. That's thinner than a human hair. That's surgical level accuracy for robots. Next, we focused on materials. We developed Sunrise NanoAlloy, a next generation aluminum alloy with the nanocrystalline structures. It's light like aluminum, but tough like heavy-duty metals. A T6 heat treatment, it heats 520 megapascal in tensile strength. That's aerospace-grade strength, now in field robots. Finally, we used SunriseVacuCast. It applies high pressure as metal cools, squeeze out micro defects. The result? 35% better fatigue resistance. That means fewer failures, less maintenance, more uptime. Want proof? A coastal utility company deployed a fleet of inspection robots. Everything was fine until storm season hit. High winds and salt spray caused joint failures. The control system worked, but the mechanic gave out. Then they came to us. We redesigned everything. Lighter structures, tight tolerances, tougher materials. The result? The new robots ran 6 months straight through storms, salt, and sun. 0 joint failures. Mission success rate 99%. And those robots, they're not just tools anymore. They are reliable partners. So, what did we explore today? We saw how Sunrise-Clara is changing the game in medical care, bringing not just precision, but reliability that saves lives. We dove deeper with Sunrise-Aqua, proving that with the right materials and process, even the ocean's toughest condition can be conquered. And we watched Sunrise-Robo turn high-tech ideas into actions, building robots that are fast, strong, and ready for anything. These aren't just upgrades, they're breakthrough. At SunriseMedCoat, we're not just making parts, we are building trust. We are not just chasing limits, we are setting new ones. DCTC isn't just a technology launch, it's the next chapter in manufacturing. Thank you for being here. Let's build the future together.